So we're going to finish up this week by looking at what's called arc length and area of a sector. Let me just draw a picture of what those two things are first, and then we'll get into like the formula to do it. So this is arc length. So if you have a circle, you draw an angle inside the circle, like that. And you want to measure the length from where the initial side hits the circle to where the terminal side hits the circle. That's called arc length. It's basically part of the circumference of a circle. It would be the whole circumference if you went around 360 degrees. But usually it's just a part of it. So that's arc length. And then area of a sector. Well, it's basically the same diagram, except we're going to look at something different in the picture. You got your circle. Let's actually let's do it in red. Initial side, terminal side. It doesn't matter how you draw the angle. Point is, you've got an angle. And what you're going to look at this time is not the length of the arc, but the area of that shape right there. So a sector basically looks kind of like a piece of pizza. It's got two sides that are straight and one side that's curved. So those are the two things we're going to look at. We'll start with that one. Okay. All right, so let me draw another picture. So here's a circle, and I'm going to draw an angle that looks like this. Because of that symbol that I just put, how big is that angle? So how many degrees would it be? 90. And here's the arc for a 90-degree angle. And it takes up exactly what Dominic just said. That is a quarter of a circle. The angle takes up a quarter of the circle, and so does the arc. All right. Now, let's go like this. How big is that angle? That's 180. How much bigger is the angle in picture 2 compared to picture 1? So it's 90 degrees bigger. So this one's 90, that one's 180. So the one in picture 2 is basically how many times the size? It's twice. The angle is twice as big in picture 2 as it is in picture 1. Now, I don't want you to look at the angle, I want you to look at the arc. How much of the circle does the arc take up in picture 1? A quarter. How much does it take up in picture 2? Half. How much bigger is the arc in picture 2 than it is in picture 1? Double. It's also double. So the point here is, if you make this angle double the size, you also make the arc double the size. If you made the angle half the size, you would make the arc half the size. When that happens, it means that the two things are directly proportional. So, angle size and arc size are directly proportional. That's not always true with everything. For example, if you look at like how much time you spend studying and the grade you get on the test, if you double the amount of time you study, it's not going to guarantee you double your grade. If you have the amount of time you study, it doesn't guarantee you're going to get half the grade. So that's not directly proportional, but this is. So as you change the size of the angle, the size of the arc changes by the same amount. When two things are directly proportional, you can set up what's called a proportion between them. So a proportion is going to look something like this. You're going to have a fraction on each side. You're going to have a numerator and a denominator on one side, and a numerator and a denominator on the other side. What we want to do is set up a proportion that looks like this, that helps us to calculate the size of an arc. The way you set up a proportion to help you figure something out is you have to put something on the left that you know to be true, and then you put on the right what you're trying to figure out. Here's kind of a simpler one. Let's say I want to convert between feet and inches. Can somebody tell me something that's true about feet and inches? And I'm going to put that on the left. Yeah?
1 foot equals 12 inches.
1 foot equals 12 inches. Is that the only thing that's true about feet and inches? No. It's the simplest one. You could say 2 feet is 24 inches. That would have been okay. But the point is, you have to put something on the left you already know. Now, how do you know this? Well, you either have to memorize it, or you have to look this fact up somewhere. But this is not a fact you can just sit down and calculate with your calculator somehow. You have to know it. Now, on the right, let's say you wanted to know 6 feet is how many inches. Put 6 feet. You put an X for inches. And does anybody remember how you solve a proportion? Yep, you cross multiply. So in this case, it ends up being 6 times 12 equals 1 times X. So we're not converting between feet and inches. We're trying to set up a proportion that helps us find arc length. But it's going to be the same idea. We're going to have to fill something in on the left that we already know. Something we learned yesterday. Let's see if we can do it. So to set up a proportion, you need 4 things. So what I've done in this diagram is I've drawn 2 angles. First angle is theta. And the arc connected with that angle, I'm calling it S. The other angle is theta 1. And the arc that's connected with that angle, I'm calling it S1. So let's see if we can set up a proportion first. Keep in mind, when you set it up, you have to set it up the same way on each side. If you put feet in the top on the left, you need to put feet in the top on the right. If inches is in the bottom on the left, inches needs to be in the bottom on the right. So you could have switched it, but you just have to be consistent on each side. All right, so here are our 4 labels. An arc, an angle, an arc, and an angle. I'll set up the left side, and I'm going to see if you guys can set up the right side. That's one way that I could set up the left. Theta 1 over S1. Now that I did that, you have to put the other 2 labels in a certain spot on the right. Does anybody see which label would have to go in the top?
Yeah. Same one that you used for the one on the left.
Yeah.
And what do we call this one? Just circle. Circle with line? Theta. Yeah. So we put the angle in the top on the left. The angle needs to go in the top on the right. And then what would go in the bottom on the right? S. Okay, now that proportion is great, but the problem is there's no numbers. We don't have like the 12 inches and 1 foot. We need to fill in one of the sides. It does not matter what specific numbers you use on this left side. Just like right here. If you want to make this a 3, and you want to make this a 36, no problem. You can do that. You just need to put something on the left that's true. Anything that's true. And I'm going to give you a hint. Let's suppose that theta 1 was 1 radian. Then that would automatically mean something about that arc. What's that? Well, it is the same as something. Does anyone remember? If you have an angle that's exactly 1 radian, the length of this arc is the same as something else in that picture. The what? The radius, yes. If you have an angle that is 1 radian, then the length of the arc is automatically the same length as the radius. And they will give you the radius in the problem. So that will be a number. All right, so there's our fact that we can use that's true. This is like my 12 inches equals 1 foot. It's not as familiar to you probably because you're not used to using it, but it's just as basic as saying 12 inches equals a foot. It's something that is true. So if the angle is 1 radian, then the arc is automatically the same size as the radius. So now, we're going to substitute our there. We're going to substitute 1 in for theta 1. And we're going to substitute r in for s1. And that gives us a true fact on the left. So we're going to have 1 over r. Do it right here. 1 over r equals theta over s. Now, I asked this earlier. Somebody already answered. How do you solve a proportion again? You cross multiply. What's s times 1? S. What's r times theta? Just r theta. And that formula that I just wrote down, that is called the arc length formula. I'll just put it over here. So in order to find the length of an arc in a circle, you need to know 2 things. First thing is, how big is your circle? Is it a really small circle or is it a big circle? And then, how big is the angle in the circle? So that's the arc length. R, what does R stand for? Radius. And theta, that represents am, represents a what? An angle. But we have to be careful about the angle. And I told you about this right at the beginning. Way back, when we came up with the conversion that was true, like that 1 foot equals 12 inches, that fact right here assumed my angle was in what units? Radians. So this whole formula was based off of a fact that used radians. Just like this formula is based off of a fact that uses feet. If you want to convert between centimeters and inches, well, this isn't the fact that's going to work. It's not based off centimeters. It's based off feet. So this formula is based off of an angle. But it has to be in radians. All right, basically the way it works, you've got 3 variables in the formula. they'll always tell you 2 out of the 3. You fill in the 2 that you know, and you solve for the 1 that you don't. So try a couple examples. Now there's 2 ways I could give you a problem. I can either just draw, I think I have one down here. I could just draw a picture and say find the length of the arc. We're going to do this one next. Well, we'll do it as our second one. Or I can just write it out as a sentence. So find the length of the arc, and now instead of a diagram, I just give you it all in a sentence form. All right. Well, it's asking me to find the length of an arc. So the first thing I should write down is my formula. Ryan, what is my formula for finding the length of an arc?
It's S equals R, and then the circle will line it.
I think Dustin knows what that's called.
I don't know.
What is it?
Data.
It's theta. Theta.
The T.
Theta. So it's like the with a ta on the end. But don't say the ta. It's theta. Okay, so there's our formula. S equals R theta. And reading through it, can somebody tell me, like, let's start with this pi over 3. What is the pi over 3?
An angle?
That's my angle. This part right here is the angle. And what letter in this formula is the angle? Theta. So that's going to go there. Okay, what about, they give me this. That's going to go somewhere too. What's the 4 inches? That's my radius. So we'll put that there. And Grady, what does S stand for?
Arc length.
That's my arc length, and that's the whole question. We don't know it. So find the arc length. So we have S equals 4 times pi divided by 3. Now, the angle is already in radians. What unit is it supposed to be in?
Inches.
Well, angles aren't measured in inches or feet. Angles are measured in like degrees or radians. So this formula, the angle is supposed to be in what? Is that what it said? Let's just go back and look somewhere. Curtis, what does it say about the angle?
It's in red.
Which is, what does that stand for?
Oh, radian.
Radians. So the angle has to be in radians. If it's in degrees and you type it in, you're wrong. You're not almost right. You're completely wrong. So we have to make sure it's in radians. This problem, it's already in radians. So we're fine. There's nothing we need to do to change it. In the next one, it's not. So we'll have to fix it. Okay, this one is fine to plug in the way it is. Okay, multiply straight across, and you get 4 pi over 3. Tony, that 4 pi over 3, what is that again? That's my...
That.
Yep, what's S? Arc length. So the second word he said, that's important, length. In this problem, what was the units that they used to measure length? Inches. So this is 4 pi over 3 inches. The rate, if you solve for R, that's a length. It should have a label like inches or feet. If you solve for S, same thing. That's a length. If you solve for theta, that's an angle. You do not measure angles with inches or feet. You measure them with radians. If they wanted a decimal, we just type it in. It's about 4.19 inches. So which one is correct? They're both correct. It depends if they want the exact answer or an approximate answer. Any questions on that one? All right, let's try this one. This time, they didn't write everything out in sentences. It's just a picture. So find the length of the arc. That's what I want to know. Okay. So Austin, can you remind me again? What's my formula for arc length?
S is equal to R times. It's not theta.
Theta. So S equals R theta. Okay, so the directions are find the length of the arc, so we don't know S. Do I know what R is? Yep. It is 8 feet. Now, this time I gotta be careful with my angle. What do I want to make sure I do with my angle first? I need to convert it to radians. If you fill it in as 130, it's wrong. So let's change it to radians off to the side. Jackson, what do I multiply by to change degrees to radians? Anyone remember from last night? Think about, we've got degrees in the top, so think about where degrees has to go to cancel and then go from there. Yeah?
Pi over 180.
It's pi over 180. Okay, degrees is gone. And both of those numbers are divisible by what? 130 and 180. 10. So easy enough, we can just go like that. So the angle is 13 pi over 18. So 13 pi over 18. Okay. And what I try to do is simplify anything I can. 8 and 18 will reduce. Curtis, what goes into both 8 and 18? Two? How many times does 8 go into, or 2 go into 8? And how many times does 2 go into 18? 9. So our final answer is 4 times 13 pi over 9. What's 4 times 13? 52. So it's 52 pi over 9. And let's just think back. What did we just find? No, we were given the angle. Angle is 130. We found the arc length. Find the arc length. So this is a length. So what should be my label on this one? Feet. In this problem, length units were feet. Alright, so there's a couple where you have to find the length of the arc. Let's try one where they give you the length of the arc. So it says we have an arc length of pi over 4, and we have a radius of 12. Now, because those are both lengths, it's very important in the problem that they use the same units. Like if one used centimeters and one used inches, well, that's a big problem. But I'm not going to give you one. That'd be kind of tricky. So They have to be the same length unit. Okay, find the angle. Alright, so Alex, what letter am I solving for in the formula this time?
You're solving for theta.
Yep, I'm solving for the theta. So let's start with the pi over 4. Kiana, what letter would the pi over 4 go in for?
Attention, please. The skills leadership is time. Thank you.
What would the pi over 4 be filled in for? The S or the R? Yeah, it's the S, because it says we have an arc length of pi over 4. So let's fill that in. And a radius of 12. 1. Where's that 12 going to go? Well, think, what is the 12? It's my what in this problem? So it says we have a what of 12?
Angle or radius?
We have a radius of 12. And what letter is represented by radius in that formula?
R.
R. So the 12 is going to go in for the R. And the directions are to find the angle. So we're going to leave that as theta. So there's our formula. Sam, how am I going to get theta by itself and get this 12 on the other side?
You can divide each side by 12.
Yep. And dividing this side by 12 is the same as putting a times 12 in the bottom of the other side. 12 is gone. And Abigail, what do I get for an angle? It's going to be a fraction. Pi over 48. And what is that? Pi over 48 what? I'm going to help her out. It's pi over 48 and it's an angle. So what's should be the unit on it, yeah? Careful, you're mixing things up. So centimeters and degrees, that'd be like if we measured like time in like seconds or feet. Feet isn't a type of unit that would apply to time. Centimeters is not a type of unit that applies to an angle. Yep. The unit on that is radians. So should I put RAD? No. We don't label it when it's radians. So whenever you solve for the angle, the unit is radians, but you do not need to put RAD. All right. Okay, I think I have one more. Where this one says find the radius. So this will be the last one we do with this formula. We're going to move on to the last one. Okay, before you use S equals R theta, does anybody see something we might want to just take care of off to the side first? Yeah.
Convert 36 degrees to radian.
Yeah, if you're using this formula, this number is not what you want. So let's just fix that off to the side. And what do you multiply by to do that, Sam?
It's pi over 180.
It's pi over 180. And 36 does go evenly into 180. Does anybody know how many times 36 goes into 180? 4. A little bit more than that. 5. Goes in 5 times. So there's your angle. Pi over 5. Okay. So Tyler, where's the pi over 5 going to get plugged in? R is what we're trying to find. So we're not going to plug anything in for R. How did we get the pi over 5? Where did that come from? The 36. And what is the 36? So you have 3 choices. The 36 would either be one of those things. You want to help him out? What's the pi over 5? Yeah?
The circle with the line.
The what?
The circle with the line.
Huh?
I'm still on the
Yeah?
Yeah.
Theta. Theta. Alright. So this is going to go right there. What about the 13? That would be the length of my arc. And that's this. Let's fill those 2 things in and see what we got. So 13 equals R times pi over 5. So we need to get the pi and the 5 on the other side, and we can move both of them at the same time. It's kind of like if you had something like this. You can move the 2 and the 3 at the same time if you multiply both sides by something. Does anybody know what we could multiply both sides by here? Multiply by what?
I over 5.
Well, that would be like if we multiplied by the same thing here. It wouldn't cancel the 2 and the 3.
Yeah, sorry, that was 5.
5 over pi. We want to multiply both sides by the reciprocal. So 5 over pi and 5 over pi. That's going to cancel the pi's. Cancel the pi's. And on the right, all we have is r. And on the left, we've got 5 times 13, which is 65. And don't forget, it's divided by pi. And that's the radius. Is the radius an angle, or is the radius a length? Naisha? It's a length. What was my length in this problem? What was the unit? Yeah, it gave me the arc length, but it gave me it as with a unit. Yeah, so it's 13. It's measured in feet. So my radius is also measured in feet. So if we wanted a decimal, we just type in 65 divided by pi, and that would be the length. It'll just depend. If the directions say round to 2 decimal places, then you'll just have to round it. If it says leave it as an exact answer, then that would be what I'm looking for. All right. Any questions on that first one? Because the second formula is pretty much the same kind of thing. Theta. So we're going to do exact same process. We're going to set up a formula, or we're going to set up an equation to figure out the formula to find area of a sector. Okay, I want to start out with the same picture I did last time. Except this time, I don't want you to focus on the arc line. Let's draw a 90. And if I draw a 90-degree angle, how much of the circle is shaded in by a 90-degree angle? 1/4 of it. Yep. Now, let's draw a circle. And if I double the size of this angle, how big would it be? This is a 90, so it would be a 180. So let's draw a 180. That's double the size. And let me shade in the area this time that's between the initial and the terminal side. So this is a 180. This is a 90. How many times bigger is 180 than 90? It's twice as big. So from picture 1 to picture 2, we doubled the size of the angle. How about the size of the area? It also doubled. So what that means about angle size and area size, they're directly proportional. If you double the size of your angle, you double the size of your area. Make your angle half as big, you make your area half as big. They're directly connected. All right, so angle size and area are directly proportional. And if two things are directly proportional, that means we can set up a, what did we do last time? Well, the true fact is going to go on one side of this thing, but the thing we're going to set up is called a, because they are proportional, we can set up a proportion. And with a proportion, you need to put a true fact on one side, and then the other side can be what you're trying to figure out. All right? Let's just worry about setting up the proportion first. And then we'll get the true fact for the left side. And so pretty much the same diagram as last time. I have an angle and another angle. But this time we're focusing on the area that's shaded in. So I have an angle and an area, and an angle and an area. So those four things are going to be what I plug into my proportion. If we set this up kind of like we did the last time, does anybody have an idea what I could put on the left? You don't have to fill in anything specific. You just have to use these four labels, or just two of them on the left.
Theta 1 over A1.
Yep, you could do theta 1 over A1. And now, what would you have to do on the right if you do that on the left? Yep, same thing. So what would go in the top?
The theta.
The theta. Very good. And the bottom? An A. Okay, so we've got our proportion, but without a true fact on one side of it, it means nothing. We have to fill in something that's true. So let's see if we can figure out something we can put there that's like 1 foot equals 12 inches. Let's go back to this picture. So this was picture of pi over 2. That was picture of pi. What if I make the angle 2 pi? How much is 2 pi? That's 360. Let's draw it. Here's my circle. And instead of drawing it at 90 or 180, I'm going to draw it all the way at 360. So here's my initial side. Here's my terminal side. how much of the circle do I shade in? All right, whole thing. If my angle is too high, the area isn't just a sector anymore. The area has now grown so big that this side kept going all the way around. And now the area is the whole shape. So this is going to be our special fact. If the angle is 2 pi, then the area is the entire circle. We just need the formula for the area of the circle. What's the formula for area of the circle? Yeah? Pi r squared. There we go. That's what we're going to fill in. So if the angle is 2 pi, then the area is automatically the entire circle. Now, we're not proving why the area is pi r squared. That's something we would just look up. All right, so let's fill that in. So let's suppose that the angle is so big it takes up the entire circle, then the area would take up the entire circle. There's your 1 foot equals 12 inches. There's your true statement. So fill this in for theta 1 and fill that in for A1. And let's see what we get. So in the top, we're going to have 2 pi. In the bottom, we're going to have pi r squared. Yeah. Yep. And the right-hand side, you never fill in. That's what you don't know. Okay, so we're going to leave that the way it is. All right. And how do we solve a proportion? We cross multiply. But before I cross multiply, is there anything I could simplify first? Yeah.
Get rid of the pies.
I can get rid of the pi's because I have 1 in the top and 1 in the bottom. So now when I cross multiply, I have 2 times a equals r squared times theta. Now that's not quite the area formula. That's a double the area formula. So I want to get rid of this too. What do I do? Yeah, you take half. So if you could divide by 2, or you could just say take half of each side. It's the same thing. And there's your formula for the area of a sector. It's 1/2 r squared theta. Okay, so A is the area. What does R stand for? Radius. And theta, that represents an angle. And what do you think we have to make sure of about that angle if we use it in this formula? It's got to be in radians. Yep. And the process here is exactly the same as last time. They'll always give you 2 out of 3 of the letters. You plug them in, and you find the third one. So we'll try a couple examples of that, and then that'll be it. So the first thing you have to be able to decide on the test is it an area problem or is it an arc length problem? Well, it tells you right in the directions here. Find the area. So we know it's an area problem. Grady, what's the formula that we just wrote down for area?
Area equals 1/2 radius squared times theta.
Times theta. Good. Okay, so find the area. So that means we're not filling in anything for A. Jenna, what's my radius this time?
Pi over 6.
So pi over 6 is inside the picture, so that would mean that that's an angle.
It would be 4 then, but it
4.
would convert it.
Nope. Nope, 4 centimeters, that's fine. We never have to convert if something's in centimeters.
Oh, okay.
Centimeters, inches, that's a length. The length can be anything we want. So radius is 4. And what's my angle? Pi over 6. What's the unit on that pi over 6?
Radians.
Radians. It doesn't have a circle on it. If it had a circle, that would be degrees. That's no good. But it's radians. Okay, let's do that out and see what we get. So follow PEMDAS. Exponent first. What's 4 to the second power? And what's half of that?
8.
So I have 8 pi over 6. But what does 8 pi over 6 reduce to? What is it? 4 pi over 3. Now let's go back and think about what we just did. What did I just find?
Your area.
I found an area. So what should I put for a label that would mean area in this problem? Yeah?
Centimeters squared.
Centimeters squared. Yeah. And that's an example where you find area. Any questions on the first? All right, let's try one where instead of doing the area, we do the angle. Even if these labels weren't here, A, R, and theta, how do you know which one has to be A? I mean, you should be able to tell, yeah?
The inches squared.
The one that has inches squared has to be area, and the one that has just inches has to be a radius. You would never measure an angle in inches, so it couldn't be that. Okay, so let's start with our formula. Ryan, we're doing a problem about area. What's our formula?
A equals 1/2 r squared theta.
Okay, so there's the formula. And let's go left to right. Sam, do I know A? Yep, what is it?
Pi over 2 squared. Inches squared.
Yeah, I'm going to leave the label off until the end, just while we're doing arithmetic. I'll put the label back if I need it. So pi over 2, 1/2. Fiorella, what's my radius? 3. And Tony, what's my angle?
And you don't know that.
We don't know that. That's the question mark. Okay, so we're going to see if we can get theta by itself. So make sure you follow PEMDAS, do the exponent first, and then we'll take half. Okay, what's 3 to the second power? 9. And I want to take half of it, but I want to leave it as a fraction. So what's half of 9 as a fraction? 9 over 2. Good. Now, we're going to do the same kind of thing here that we did a couple problems ago. We want to get rid of the 9 and the 2 at the same time. So we have, what would we multiply by to do that? Multiply by the reciprocal, which is? 2 over 9. Perfect. So 2 over 9. 2 over 9. 2 in the bottom, 2 in the top. 9 in the bottom, 9 in the top. Everything's gone from the right side. And what do I get for an angle? Pi over 9, because the 2's are gone here too. And what's the label on that? Radians. Okay, so that's pi over 9 radians. All right. Any questions on that one? Okay, so in the homework is going to have a couple problems about a clock. And it's going to ask a question like, how far does the tip of the minute hand move from 12 to 4? So the tip of the minute hand's on 12, and then it moves to 4. That thing that I just drew in red, what is that? That's an arc. So you're going to be finding an arc length. And what would the length of the hand on the clock be? That's your radius. That's the distance from the center to the edge. Now the only thing you have to figure out, and they won't tell you that, is the angle. They'll tell you the length of the hand on the clock. But the nice thing about a clock is everything's equally spaced. So think about from like something simple. Think about from 12 to 3. How many degrees from 12 to 3? There's 90 degrees between 12 and 3. So that means every hour is how many degrees? How much? 30. 30, 60, 90, 120, 150, 180. So you can easily figure out the angle on a clock. They're not going to give you one like 1230 or something. It's either going to be right on the 12 or right on the 3 or the 4. So you can get the angle knowing every hour is 30 degrees. Now, I think they're going to give you one problem also about a pendulum. They're going to ask you, as a pendulum swings back and forth, how long the path is. Well, as it swings, it's going to make that line in red. What is that shape? That's an arc. So as a pendulum swings back and forth, it makes an arc. And the length of the pendulum would be your what? That's your radius. From there to there. That's the distance that it's swinging from the center. And they'll give you something like an angle. You know, they might say it's like 30 degrees as it swings from there to there. So they'll give you the angle, they'll give you the length of the pendulum, and you have to find the arc. But that's two of the questions that I just remember from the homework. Any questions on that? Okay, so what is on the test tomorrow? So it's going to be distance formula, midpoint formula, changing between degrees to radians and radians to degrees, arc length, and area of a sector. Distance and midpoint formula, that was Monday. Converting between degrees and radians, that was Tuesday. Arc length and area of a sector was today. That was Wednesday. Those are the 5 topics on the test. And the homework is 71 to 87, just the odd on that part, and 91 to 94. That's all. Does anyone have any questions about the topics that I listed for the test? Remember, you can make a reference sheet, so I would advise you, if there's anything you can't remember, put it on the sheet.